This is shocking. We're having an asteroid coming in at us in a couple of hours with the Yarkovsky Effect. Asteroid shock, dangerous space rocks being thrusted towards Earth by the Sun. I guess we've all noticed that we've had a really big uptick in the number of asteroids that have been coming at us. One was spotted yesterday, and it was beyond the moon, and the agencies told us that there was no way that this was going to impact Earth. Well, it did impact us, and it fell in the Caribbean, thank goodness. It didn't hit any city. It was a small asteroid, but still, they did not expect it in any way to impact the Earth, and it did. How did that happen? Anyway, this is by Naomi Adedokun on Express UK. From what the astronomers have been telling, the asteroids heating up in Earth's orbit are beginning to face away from the Sun and changing their trajectory towards Earth. NASA scientists say that space radiation is acting like a small thruster. This is the first I've heard of something like this. All right, asteroids are being heating up in Earth's orbit, beginning to face away from the Sun, changing their trajectory and coming towards Earth. And scientists explain that this is because space radiation is causing them to act as if they have small thrusters. PhD meteor specialist Helena Bates spoke to the Natural History Museum concerning this hazardous asteroids in Earth orbit as NASA's OSIRIS-REx mission attempts to understand the dangers of these space rocks. She says most of the asteroids in our solar system are leftover rocky bodies from the beginning of the solar system. That's of course a theory, but anyway, that's what they believe. Most of them are between the orbits of Mars and Jupiter, but there are a number of them near what we call near-Earth space. These are the near-Earth objects. And she said you would think that predicting the orbit of an asteroid would be quite easy, and in principle it is, as she explains, but the problem with very small bodies are that they're affected by things that we did not initially assume that they would be affected by. And one of these effects is the effect of the Sun, which is called the Yarkovsky Effect. This effect was discovered by Polish civil engineer Ivan Osipowicz Yarkovsky in 1900. The Yarkovsky Effect. Ms. Bates continued saying the Yarkovsky Effect is basically when the Sun heats up one side of the rotating body of the asteroid. So the asteroid is rotating as it orbits the Sun. And as one side heats up, it kind of absorbs the heat. And then as it rotates, that side will begin to face away from the Sun and will radiate that heat outwards. That basically acts like a small thruster to push the asteroid into a slightly different orbit. And because the amount of heat that the asteroid absorbs is to do with things like composition that the asteroid is made of, which we don't know, that means it's really hard to predict the effect of the Sun on the asteroid. These asteroids can sometimes be in the solar system, absorbing Sun for billions of years. Scientists discovered that this sometimes makes some big differences to their trajectories. Bates added that some of the asteroids that are in the asteroid belt can be deflected so much that they come onto Earth crossing orbits. These are the ones that are dangerous to us because if they're crossing Earth's orbit, there is a very, very small chance that Earth might be there when they're crossing Earth's orbit, of course. And she goes on to explain, so we're looking into it, and scientists are very interested in the effect of this. It's actually one of the focuses of NASA's OSIRIS-REx mission, which is a sample return mission. The U.S. Space Agency's goal for the mission is to obtain a sample of a near-Earth asteroid and return the sample for a detailed analysis. And this was launched in September 2016. Bates said the mission's currently in orbit around one of those potentially hazardous asteroids, and it's investigating the effect of the Yarkovsky effect on this asteroid's orbit. So hopefully we should get a better handle on how the sun heating up one side of the asteroid affects the orbits. Now, the Yarkovsky effect is a force, as we said, acting on the rotating body in space caused by the anisotropic emission of thermal photons, which carry momentum. And it usually is considered in relation to meteoroids or small asteroids, as its influence is most significant for these bodies. The mechanism, the Yarkovsky effect, is a consequence of the fact that change in the temperature of the object warmed by radiation, and therefore the intensity of the thermal radiation from the object, lags behind changes in the incoming radiation. That is, the surface of the object takes time to become warm when first illuminated and takes time to cool down when illumination stops. In general, there are two components to the effect: the diurnal effect, rotating body illuminated by the sun. The surface is warmed by solar radiation during the day, cooling at night. Due to the thermal properties of the surface, there is a lag time between the absorption of radiation of the sun and the emission of that same radiation as heat. So the warmest point on the rotating body occurs around 2 p.m. sight on the surface, or slightly after noon, resulting in a difference between the direction of absorption and re-emission of the radiation, yielding a net force along the direction of motion of the orbit. If the object is prograde rotator, the force is in the direction of motion of the orbit and causes the semi-major axis of the orbit to increase steadily. The object spirals away from the sun, retrograde rotator, spirals inward. Diurnal effect is the dominant component for bodies with diameter greater than about 300 feet. The seasonal effect is the easiest to understand for the idealized case of non-rotating bodies orbiting the sun, for which each year consists of exactly 1 day. As it travels around its orbit, the dusk hemisphere, which has been heated over a long preceding time period, is invariably in the direction of the orbiting motion. And the excess of thermal radiation in this direction causes a braking force that always causes spiraling inward towards the sun. In practice, for rotating bodies, the seasonal effect increases along with the axial tilt. It dominates only if the diurnal effect is small enough, and it may occur because of very rapid rotation, no time to cool off on the night side, hence an almost uniform longitudinal temperature disturbance. Small size, the whole body is heated throughout, or the axial tilt close to 90 degrees. The seasonal effect is more important for smaller asteroid fragments from a few meters up to 100 meters, that is 300 feet across, provided their surfaces are not covered by an insulating regolith layer and they do not have exceedingly low rotations. Also, on very long time scales over which the spin axis of the body may be repeatedly changed due to collisions, the seasonal effect will, of course, tend to dominate. In general, the effect is size dependent and will affect the semi-major axis of smaller asteroids while leaving large asteroids practically unaffected. For kilometer-sized asteroids, the Yarkovsky effect is minuscule over short periods. The force on asteroid 6489 Golevka has been estimated to be about 0.25 Newton for a net acceleration of 10 to the minus 10 minutes per square second. It's steady over millions of years. An asteroid's orbit can be perturbed enough to transport it from the asteroid belt to the inner solar system. That's how they can be affected. Small asteroids, over millions of years, the asteroid's orbit can be perturbed enough to transport it from the asteroid belt to the inner solar system. Unbelievable. The above details can become more complicated for bodies in strongly eccentric orbits, of course. This is the details we just read from Wikipedia on the Yarkovsky effect. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.